all, this is Jess Clary with Jess Clary Auto Repair in Elizabethtown, Kentucky. I wanted to do a little different video today. I want to go over one of the diagnostic procedures that we use. I think I'm maybe going to do a little series of some videos on some of the diagnostic tests that we do that are not scanner related. There's a little bit of a misconception with the public. Occasionally I get a call, and start speaking to someone about diagnosing their vehicle, and they say, regarding the cost, say all that just to hook it up to a computer. So there's a kind of misconception that you just hook up to a scanner and it tells you what's wrong with your car, and that couldn't be further from the truth. No scanner can diagnose your car, and a code read is not a diagnosis. So I want to do a little bit of some informative videos about some of the procedures we use, and I think I'll key on a few of these that are not scanner related. So this specific test that I'm going to talk about today is a fuel composition test. And first of all, I'd like to go over a little bit, when we might want to use this test. So a lot of times our initial procedure is to connect a scanner to the car, pull the codes, maybe look at some live data, because this is a quick way to gather data, and it may give you a direction to start your diagnostic process. So if we've gathered, pulled codes and maybe seen some lean codes or some rich codes on either of the banks, and oftentimes then we'll go in and analyze the fuel trim data. So you can make a whole separate video about fuel trim data, analysis. There are some good ones out here on the internet. So if you're interested in that, do a little search there and start doing a little bit of studying on fuel trim diagnostics. It can be very useful once you've learned it and give you quick direction. So when we might want to do a fuel composition test is generally when we see fuel trims on a port injected engine. I'm speaking of here. This would be different for a GDI engine, a direct injected engine, but on a traditional port injected engine, generally when we see fuel trims that are even throughout the RPM and load range. So you drive this vehicle dynamically while watching your fuel trim data, and say we see a fuel trim of positive 15%, but it's positive 15% at idle, positive 15% at 2500 RPM, positive 15% at 3500 RPM, approximately positive 15% throughout the various ranges of load as we load it under heavy acceleration, medium, light acceleration. Anytime we see a fuel trim that is about the same amount throughout the RPM and load range, there's not too many things on a vehicle that can be on a traditional port injected vehicle. We usually look at mass airflow sensors being skewed. We look at our fuel compensation. Sometimes we can look at a skewed sensor, maybe a skewed oxygen sensor. But there's not too many things that can cause a linear fuel trim like that. So one of the easiest and quickest to rule out is the fuel composition. If you are working on a non-flex fuel vehicle and you think maybe someone's added flex fuel by mistake at some point, or if you're working on a flex fuel vehicle and you think the fuel composition sensor on the vehicle is maybe skewed and not reading correctly. So I'm going to walk you through real quick an easy test here. We just traditionally pull a fuel sample, usually with the fuel pressure gauge that we can screw right onto the fitting on the fuel rail if it's available and easily accessible. That's a quick way to grab a fuel sample out of the car, and I have a little fuel sample here, so I'm going to get you set up and run you through this test real quick. Okay guys, I've got everything here I need to run this test. We've got a graduated cylinder. Doesn't have to be this fancy. You can use anything you have that's graduated. I've put 10 milliliters of water in the bottom of it, just tap water. I'm going to put this fuel on top of it, and I'm going to put 10 more milliliters of fuel on top of this. I like to use multiples of 10 because we want to know how many. What's going to happen is the alcohol is going to go to the water and come out of the gasoline. So if we use a multiple of 10, it's real easy to figure what percentage of alcohol we have in our fuel. We need to know that so we know if we have flex fuel or if we just have around here we usually have 6 to 10% fuel alcohol in our fuel. So I'm just going to get 10 milliliters, 'cause that's what my cylinder's graduated in, of gasoline here. Okay. Oops, spilled a little. We were on 10, so we're going to add fuel till we get to the 20 milliliter line. Okay. Then we're going to shake it. Be careful with glass, we'll build pressure and break it. And what's going to happen, we agitate this real good. Any water or any alcohol in this fuel is going to bond to the water. The gasoline is going to sit on top. So you'll be able to see a line of separation as this all settles. And when we started right at this line, we have 10 milliliters of gas on top of that. In this case here, I only have, each of these graduations is a half a milliliter. So I only have, or 5%, excuse me, in this fuel. Each milliliter is 10%. Each one of these is a half a milliliter. So I have 5% alcohol in this fuel. And that gives me some information. So if my alcohol content sensor is showing that I have 15% and I only have 5, we can say we have a skewed sensor. Or if I'm working on a non-flex fuel vehicle and I have over 10%, maybe I have 65, 75, 80% alcohol in my fuel, someone mistakenly put flex fuel in the tank. So this is just one of the many diagnostic tests we use to try to come to a complete diagnosis, and just thought I would do maybe a few little videos here on some tests that are not scanner related, because there seems to be a bit of a misconception with a lot of the public that this is all a matter of plugging up a scanner and it tells you what part to put on. So guys, you all have a good day. This is Jess Clary with Jess Clary Auto Repair in Elizabethtown, Kentucky. Thank you so much. Bye-bye.